So hello students, uh, this is the 14th video. I'm going to continue with question number 4 from exercise 1C. In the 13th video, I explain you the process and steps involved in solving question number 4.1, where I've showed you how to find HCF and LCM of these two given positive integers by applying the fundamental theorem of arithmetic. So we have done 4.1. So today in this video I'll show you how to solve 4.2. I've asked you to try by yourself, but in case for those who have not understood properly, you can see this video and you can learn it how to do. Okay, so this is 4 number 2. So you can see the given positive integers are 225 and 867. So let's do number 2. 225 and 867. So here's the solution. So students, if you have seen video number 13 nicely, then you know what to do, the steps involved. So first of all, you have to find the prime factorization of these two composite numbers by applying fundamental theorem of arithmetic. After that, you have to write their prime factorization in ascending order in power notation or in exponential form with powers. Then after that, you have to find HCF and LCM. Before I do the sum, let me tell you once again how to find HCF. HCF is found by multiplying only the common prime factors with their lowest powers, and LCM is found by multiplying all the prime factors with their highest powers. Okay, so let us start then. So we take 225 for prime factorization, and we take here 867 for prime factorization. And still I'm telling you once again, please by heart all these prime numbers from 1 to 100. Okay, so whenever you do prime factorization, always begin with 2. That is, we need even number. Okay, if it's even number, divide by 2. If it's not even, then you try by other numbers. Okay, so let's see. 225, as you know that because of this unit digit 5, it is not an even number, it is an odd number. Okay, this given number 225 is an odd number, so means this prime number 2 cannot be used here to prime factorize. Okay, because this is odd number. So since 2 cannot be done by 2, so now we'll try by 3. And remember students, if you want to divide by the next prime number 3, better you always do, if it's a big number, then you should always do a test. Okay, test of divisibility. What is the test? You add all the digits numbers and the total should be a multiple of 3. The total should be present in the table of 3. It should come in the table of 3. So let's add, let's find the sum of these digits. 2 plus 2 4, 4 plus 5 9. That means the total is 9. And if you recall table of 3, yes, 9 comes in the table of 3. 9 is a multiple of 3. 3 3s are 9. Total is 9 and 3 3s are 9. 3 3s are 9. So yes, in the table of 3 9 comes, so that means we can divide by 3. So if I take only 2 small, so let's take two digits together, that's 22. Then keep seeing table of 2, keep like recalling table of 2 in your memory. So you'll find that 3 7s are 21 because 3 is 24 big, 3 8s are 24 big, so we'll not take bigger, we'll take smaller. 3 7s are 21. Then 22 minus 21, 1. 1 goes, that remainder 1 goes and joins with 5 from the left. That means 1 carry 1 and this 5 becomes 15. And then again see table of 3, 15 here. So 3 5s are 15. Okay, so in this way we got 75. Now since we have just now done with 3, we have done prime factorization with 3, prime number 3. So that's why again you try by 3. If you cannot do by 3, then you try by 5, 7, 11, so on. But first you should try by 3 itself because you have done this now by 3. So for 3 again same thing, you add this 7 plus 5 12 and 3 4s are 12. The 12 is a multiple of 3. So yes, you can divide by 3 because the total is 12 and 12 is a multiple of 3. 12 comes in the table of 3. So again let's do. So first pick only 7 because it's bigger than 3. 3 1s are 3, 3 2s are 6, 3 3s are 9. 9 is bigger. So we'll not take 3 3s are. We'll take 3 2s are. 3 2s are 6. 3 2s are 6. Imagine the small 6 and subtract 7 minus that 6. 7 minus 6, 1. 1 goes and join with 5. The 1 and 5, 15. And 3 5s are 15. So now 25. So if you want to try again by 3, then let's add 2 plus 5, 7. And we know that 7 doesn't come in the table of 3. 7 is not a multiple of 3. 3 1 is 3, 3 2 is 6, 3 3 is 9. 7 doesn't come. So that's why I will not do by prime number 3. So if you cannot divide by 3, then you go to 5. Then can you divide this 25 by the prime factor of 5? Yes, by the prime number 5, yes, because most of you know table of 5. So 25 comes table of 5. So 5 5s are 25. Okay. Now 5 coming. So you can see that there's a 5. But we all know that 5 is a prime number. So the prime number always divide by itself. 5 1 times 5. 5 1 is 5. If you get 1, then stop. Okay. So this is the prime factorization of 225. Now same way we'll do for 867. So first of all, again same thing. To do prime factorization, first we should try by 2. But then check, is this even number or odd number? Because even number you can you do by 2, but odd number don't do. So 7, how to identify prime and how to identify even and odd. If the unit digit of any given number is 1 3 5 7 9, then that is odd. And since 7 is there, so it is odd number. So odd number we cannot divide by 2. We cannot divide by the prime factor 2. Okay, 2 is not a prime factor, that means it's odd number. So cannot do by 2, then we should try by 3. And for 3, same rule. For 3, you do the test, you add this, and if the total is multiple of 3, then you can divide by 3. So let's add 8 plus 6 14, 14 plus 7 21. And if you think properly, if you recall table of 3, then 21, yes, it comes in table of 3. 3 7s are 21. Total is 21 and 3 7s are 21. 21 is a multiple of 3. Yes, we can divide by 3. Okay, so let's pick only 8 first because 8 is bigger than 3. 3 1 is 3, 3 2 is 6, 3 9 bigger, so 3 2 times 6. Then 8 minus that small 6 which is there, which you just imagine is here. So 8 2 is 6, 3 2 is 6, sorry, 6. Then 8 minus 6, 2. That 2 goes and join with 6. So 2 and 6 26. Then density of 3. 3 is 24. Remember it's 26. Okay, 26. 3 8s are 24, small. And 3 7s, 3 9s are 27. 27 is big. It's 26 and 27 is big. So we'll not take 3 9s. We'll take 3 8s. 3 8s are 24. 24, it's 26, 24. From 26 you subtract 24, it comes 2 again. Carry 2. Then that 2 goes and join with 7, become 27. And 3 9s are 27. Okay, 3 9s are 27. So let's divide complete. Since we have done by 3, let us again divide by 3 again. Let's try. Okay, let's do the test. So let's see whether we can divide this by 3 or not. So let's see. So first you add 2 plus 8 10, 10 plus 9 19. That means the total is coming 19. Now tell me, does 19 come in the table of 3, or is 19 a multiple of 3? Then quickly recall table of 3. 3 5 15, 3 6 18, 3 7 21. 3 6 18 and 3 7 21. 18 and 21. That means 19 don't come, but some here 19. The 19 is not a multiple of 3. That means we cannot divide by prime number 3. Okay, if you cannot divide by prime number 3, then you should try now by next prime number 5. But you know the tests I've already explained in the previous videos, how to test whether a number is divisible by 5 or not. See how to test. Any number is divisible by prime number 5 or factor 5 or by 5 if the unit digit of that given number is either 0 or 5. That means if the unit digit is either 0 or 5, we can divide by 5. But see, here the unit digit is neither 0 nor 5, it's 9. So it's confirmed that now this 289 cannot be divided by 5. Okay, clear? So since we cannot divide by 5, now whose turn next? Next is for 7. For 7 students, there is no test. So you have to divide this 289 in the rough by 7. So let's divide 289 by 7. If remainder comes 0, then it's a factor. Okay, there's no test, shortcut test, so we'll divide actually. Okay, 7 4s are 28 and 7 1s are 7. That means now nothing to come down. So look, is the remainder 0? No, remainder is not 0. That means what? Since remainder is 0, the remainder is not 0. So therefore 7 is not a factor of 289. So 7 prime number 7 is not a prime factor of 289. So means 7 also gone. Now whose turn next? Now we should try by 11. So in this way, now again 289, let's try to divide by 11. 11 2 is 22, then 6 9, 11 6 is 6 6. And see, here also remainder is not 0. When I divide by next prime number 11, I see the remainder is not 0. That means 11 is also not factor. 11 also not factor of 289. In this way, now we'll try to divide 289 by next prime number is what? 13. 13 2 is 26. Again 13 2 is 26. Again say remainder is not 0. That means what? 13 is also not factor. Okay, not factor. 13 is also not factor. Then if 13 is not factor, then comes 17. So again divide now 289. Now let's try by the next prime number 17. Okay, 17 ones are 17. Okay, small. 17 twos are 34. 34 is big, so we'll do 17 ones are 17. Okay, now 8 minus 7 1, 2 minus 1 1. Whose turn to come now? 9 means 119. Now 17 how many times? Let's try by 7. 7 7 is 49. 4 carry and 9. 7 7 8 9 10 11. So it's coming. That means 17 sevens are 119. Remainder is 0. See, look. That means this 289 we can divide completely by the prime number 17. So yes, 17 is a prime factor. So let's divide by 17. So see, whatever answer is coming, because since you've already done rough, so 17 is coming, we can directly write 17 here. Let's check. 17 ones are 17. Then 20 minus 17 come what? 11. 11 9 19. 119. And 17 7 is 119. Means you can just write this answer here directly. Okay. Now look. We have to continue further. But you see that we have got 17 here, and we all know that 17 itself is a prime number. And I've been telling you always in all the videos that whenever you see any prime number coming here, then directly divide by itself. So this 17 prime number will divide by itself. Okay, so 17 ones are 17. So since we have got 1 here, that means we have finished the prime factorization here. Okay, so now, but still the process still left, because we find HCF and LCM. So to find HCF and LCM, let us do the, so first we'll write here, because the question clearly is telling us that find the HCF and LCM of this given pairs of integers by applying fundamental theorem of arithmetic. So in fundamental theorem of arithmetic says that any positive integer can be decomposed or factorized as a product of prime numbers, okay, or prime factors. So that's why now we'll apply here. Therefore by applying the fundamental theorem of arithmetic, we have, so what do we have? 225, this composite number can be expressed as the product of prime factors, 3 into 3 into 5 into 5, which gives us 3 is a prime factor. So write once, and then how many times coming? 2, so we write in power notation. 5 also prime factor, and 5 coming 2 times, write it as exponent 2, okay, power 2. So 2 and 5 finished. Let's do for 867. So for 867 we got prime factorization 3 into 17 into 17. Composite number is equal to product of prime number. These are prime numbers. So now write in power notation 3 is only one time, and 17 2 times, so 17 square. Okay, so we have finished the prime factorization of these two. Now we have to find HCF and LCM. The first HCF. Therefore HCF of 225 and 867 is equal to, remember how to find HCF? I told you in question number 1 also I have solved. To find HCF, let me tell you once again, HCF is the product of all the common prime factor with lowest power. Means we should add only the common prime factor, then also with the lowest power. So if you look at the prime factorization of 225 and 867, see the prime factorization. Can you see, students, which is the common prime factor here? Common, same, which is present in 225 and 867 also. So please mark them. 3 and 3 are common. Look, as I have underlined here. 3 and 3 are common prime factors, so we'll write only once. Okay, after marking the common prime factor 3 and 3, write its lowest power. So here 3 has power 2 and here 3 has power 1. So which is smaller? Which is the smallest? 1. So write 3 power 1. Now see, in 2 and 5 we have the prime factor 5, but you can see that in 867 there's no 5, so means 5 is not a common prime factor. Same way in 867 we have 17 as prime factor, but in 225 17 is not there. Means what? 5 is not common and 17 is not common, means they are present in only one numbers, okay, in one of the given numbers each, but 3 is present in both, so 3 is common prime factor. 3 is also means what? In this sum, in this particular sum, 3 is the only common prime factor and written with the lowest power, that is 1, and there's nothing other, so we'll leave like this only. But to get the final answer, now see, we'll remove this power 1. Had this in power square, the 3 square means 3 into 3 9. In power 3, the 3 into 3 3 times. Means what? But 3 is the power what? 3 is only one time. That means what? That means the HCF, the highest common factor of these two given positive integers, is only 3. This is the HCF, okay, the HCF form, okay. Now we'll find LCM. Therefore LCM of 225 and 867. So how to find LCM? Remember students, I told you LCM is nothing but is the product of all the prime factor. Means what? Listen to the word. In HCF is the product of only the common prime factor with lowest power, but LCM is the product of all the prime factor with highest power. LCM is defined as what? The product of all the prime factors, means all the prime factors which are present in these two given integers, okay, all the prime factors right here, they're also with highest power, and then multiply them. So see now, which are the prime factors here, which are the prime numbers, tell me present here. You can see that the prime numbers are here 3, right, in ascending order. The smallest prime number first, then the next prime number is 5, and the next prime number is 17. So 3 is a prime factor, so write once. 5 is also a prime factor, 17 is also a prime factor. They say there's no other prime number in these two numbers, there's no other prime number. 3, 5 and 17, these are the prime numbers. See, 3, 5 and 17, okay. So write all the prime numbers. Now write their highest power. After writing all the prime factors, prime numbers, write the highest power. In this 3, the highest power is 2. In this 5, the highest power is also 2. In this 17, the highest power is also 2, okay. So all are square, okay. So now let's multiply them. So first of all, remove, so express them from power notation to normal form, standard form. So 3 square means what? 3 into 3, 9. It doesn't mean that 3 into 2, okay. 3 into 6 is wrong. It's 3 square means 3 into 3, 3 into 3, 9. Now 5 square, 5 into 5, 25. It's not 5 to the 10, it's 5 into 5, 25. 17 into 17, how much? 289. You multiply that off, will come to 89. Like, so let's see here, you can see here also 17 17 289, okay, will come to 89. You could see, if you multiply that off also, you'll get 17 into 17, not 17 into 2. It doesn't mean 17 into 2, it means 17 into 17 2 times, so you get 29. And now multiply all this, 25 into 9 into 29 in the rough, so what you'll get, see, 25 into 9, 9 5 45, then 9 to 18, 18 plus carry 4, 22, okay. Now in this 225 we multiply 289, okay. So 9 5 45, 9 to 18, 9 to 18, 9 20, 8 5 40, 4 16 20, and 7 18, 25 10, 2 4 5, 2 4 5 2 0 15, 6 5 0 2 5. It's 65,025. So yes students, we have got the LCM. So that means for this question number 4.2, for this two given numbers, their HCF is 3 and the LCM is 65,025, okay. So thank you students, you practice these sums nicely, okay. Only by saying and copying will not do, you have to practice all the sums, okay, whenever you have any time, okay. Thank you.